Good morning, this is Mr. Shields back again with another video. Today's topic, we'll be looking at multiplying radicals. This is an old topic that we've covered here before, but once again, like I mentioned in a previous video, we're going to be reviewing certain old topics in preparation for your classes next year. Next week, we will begin a brand new topic, but in the meantime, let's dive right into multiplying radicals here. As you notice here, the steps at the very top, multiplying the coefficients or the numbers that are in front of the radical sign first. Step two, multiplying what's within the radical sign. And then finally, we're going to simplify here. All right, so let's dive right into number one here. And if I look at number one, I have the square root of 8 times -3 square root of 2. And if you'll notice, they don't write the imaginary 1 that's in front of the 8. So I'll go ahead and write that in here. So I'm going to multiply my outside. So 1 times -3. So 1 times -3. And that'll give me a -3 on the outside. On the inside, I would be multiplying my 8 times 2. All right, and when I do that, I'm going to have the square root of 16. Now, I'm not done because if you notice, we did step 2 already. We multiplied what was on the inside, so 8 times 2. We multiplied what was on the outside, 1 times -3. And that's how we got that. And now I have to simplify. And if you notice, 16 just happens to be one of our perfect squares. So the square root of 16 is 4. So once I take that square root, that radical sign disappears, and then we'll multiply that times -3. So -3 times 4 is just a -12, and that's going to be my final answer. Let's take a look at example number 2 here. Once again, you'll notice there's an imaginary 1 here that's not listed, and I have a negative sign here, so that would be an imaginary -1. So I'm going to multiply my outsides first. So 1 times -1. Once I do that, I'll end up with a -1 on the outside here. And then I'm going to multiply what's on the inside. So that 3 times 2, I'll multiply those, and I'll get the square root of 6. Now, that's my final answer. But as some of you probably remember, I might write it like this, okay? And this is probably the way you would see it most often written without the -1. Sort of understood here, that's there. All right, let's dive into number 3. And if you'll notice in our example on number 3 here, we now have numbers other than 1 as our coefficients. So we have a 5 times that -7. So we can multiply those. And I'm going to end up with a -35 on the outside, okay, once I've multiplied those. On the inside of my radical, I'm going to have the square root of 10 times the square root of 12. And so when I multiply those under the radical sign, I'm going to end up with the square root of 120. Now that we've multiplied the outsides and the insides, we can go ahead and actually simplify what's on the inside of that radical. So we'll use our perfect square card that I have here that I've been moving around a bit. We'll just go ahead and try to find out what the biggest perfect square into 120 is. And strangely enough, the biggest perfect square just happens to be a 4. You wouldn't think that, but it is. So I'm going to go ahead here, the square root of 4. And also, I'm going to have to do 120 divided by 4, which is going to give me a 30. I'm going to bring down my -35 for the ride here. And so my final step will be taking the square root of 4, which is just, you guessed it, 2, times a -35. And I kind of ran out of room here, but that's okay. And so I'll multiply these two together, -35 times 2. I'll end up with a -70. And of course, we can't forget about our square root of 30. That'll be my final answer here. All right, number 4 here. Once again, we're going to multiply our outside numbers or coefficients. So we'll have -4 times 2 on the outside. And then when we multiply that, we end up with a -8. Under the radical signs, we're going to multiply the square root of 14 times the square root of 8. And when we do that, we're going to end up with 112 as our number. We're going to come back here and look at our perfect square cards. I want to try to find out the biggest perfect square that goes into 125. I'll write my radical signs and see if you can guess what that number will be. And the number is 16. Okay. So 112 divided by 16 is just 7. So that's my other term under the radical sign. I'll bring down my -8 here. And then it's time to simplify to get our final answer, okay? So the square root of 16 is 4 times that -8 on the outside. And once again, as you guys can see, I'm running out of room, so some things never change. Once I multiply these numbers, -8 times 4, I'm going to end up with a -32 square root of 7. Okay, so that's probably the more straightforward examples here of multiplying radicals. As you notice, once I've highlighted my answers here, what you'll notice is that they do change a little bit. So I'm going to skip on down to the bottom of this paper here. Fortunately for you guys, you don't need to worry about examples like 5 through 8 here, which have the variables, the activity that you guys are going to be working on, so you don't have to worry about that. So let's take a look at another type of multiplication of these radicals here. So we're going to look at examples 9 and 10 here. And if I look at 9 and 10, you'll notice that they include something else in addition to multiplication. So if I look at number 9, I have 10 square root of 2 times the 3 square root of 10 minus 6 square root of 5. So let me highlight those multiplication and subtraction signs. So think of it like an order of operations problem, okay? So if I had 10 times 3 minus 6, which would I do first? Well, I would do the multiplication first because of order of operations. So I'm going to do the exact same thing here. I'm going to go ahead and multiply here first, and then I'm going to subtract that 6 square root of 5. So first things first, we'll multiply our outside numbers here. So 10 times 3, which is going to give me 30. Then I would multiply what's on the inside here. So I would have 2 times 10, all right? And so I would end up with the square root of 20 here. All right, so remember, I'm just focusing on these two terms right now, okay? So I'm gonna go ahead and simplify this. I'm gonna try to find out the biggest perfect square that will go into 20. And the biggest perfect square, I believe, will be number 4. I'm gonna write down my 30 here. And 20 divided by 4 is just 5. And then we can simplify. The square root of 4 is just 2. We'll multiply that by 30 here. And so when we do multiply that, 30 times 2 just gives me a 60. So we'll have 60 square root of 5. But that's not my final answer because you'll notice we have to deal with that third part, which is subtract 6 square root of 5. So I'll write that down here. And so now this problem gets to be pretty easy. So for those of you who've done the last activity on adding and subtracting radicals with me, you notice that once I have the same sign under the radical sign, then I can either add or subtract my coefficients. So 60 minus 6, I'm going to end up with a 54 square root of 5. Okay, so we're using both skills here, the multiplication as well as the adding and subtracting component. All right, so with that in mind, I'm going to show you another type of problem in the next video. So I'm gonna go ahead and pause right here, and you can go ahead and look at part 2 of our video on multiplying radicals.